Oh yeah, scuba diving. One of the most popular bucket list items. I mean, it should be. Look at it. It's beautiful. Oh, look at this guy. He thinks he's so cool, but wait! Do you know the safety precautions? What's that? Oh, okay. I'll tell you that and what gas cells have to do with it. But first, let me tell you the history, because that's important. Throughout history, there have always been divers. The only problems were not being able to hold your breath long and the worry of going too far and not making it back up in time. By the turn of the 20th century, two types of diving equipment were created: open circuit and closed circuit. Open circuit involves the diver's exhaled carbon dioxide, which vents into the water, and the closed circuit is where the diver's carbon dioxide is filtered from the unused oxygen and then recirculated. The only problem was the deeper you went, you were at higher risk for developing oxygen toxicity. Here are the symptoms. The first practical diving equipment was created by Henry Floyce in 1878. During World War II, the Germans, British, and Italians used oxygen rebreathers for combat divers. In 1952, Major Christian J. Lambertson made a modification to the oxygen rebreather and called it Scuba, self-contained underwater breathing apparatus.
Now, what do the letters stand for? We've gone over this before.
Self-contained underwater breathing apparatus.
By George, she's got it! Self-contained underwater breathing apparatus! And who invented it? Magellan!
Scuba divers breathe compressed air, which is 78% nitrogen and 21% oxygen. This gas is carried in a cylinder on your back. You can't breathe directly out of the tank because the high pressure would damage your lungs. To solve that problem, the tank is attached to a regulator. It reduces the pressure so it's possible to breathe it, and it supplies your air. Divers have gauges that tell them what the air pressure is, their depth, and a compass for navigation. Now that you know the history, let me tell you about volume, temperature, and pressure. Volume is the space an object takes up. Imagine a cup of water. The water takes the shape of the container. In this example, the volume of this container is about 32 milliliters, but make sure you always use your units! Alright, I'm sorry, moving on. Temperature is a measurement that indicates how hot or cold something is. That's what a thermometer does. The higher the bar rises, the temperature is hotter. Pressure is the most important thing to know if you are going scuba diving. Pressure indicates force, which changes how particles react. There are many kinds of pressure. The one we're talking about is atmospheric pressure. Atmospheric pressure is pressure within the Earth. Now that you got that, I can explain the gas laws. Scuba diving involves several gas laws, one of which is Boyle's law. It means when the temperature remains constant, the volume and pressure change. Another way to look at it is by using this PTV stick my cat loves to play with. You hold the temperature constant. When the pressure increases, the volume decreases, and vice versa. The gas particles are compressed when put into the tanks because they're going in a small container. The particles are forced close together. When a diver inhales air from the tank, the pressure of their lungs will be 1 atm. When the diver descends, the pressure will be greater, 4 atm. This is 4 times the typical volume. This will lead to injury. Another gas law is Charles' law, which keeps a constant pressure. With the pressure constant, the temperature and volume both increase and decrease together. It's important in scuba diving to exhale as you ascend because if you hold your breath while going up, the air in your lungs expand, which can cause injuries. Another reason to understand gas laws when scuba diving is to properly store the gas tanks. Never leave them in the hot sun or in the trunk of your car because of Charles' law. When the gas particles are heated, they take up more volume and the pressure increases. With the particles having nowhere else to go, the tank will. When you think of gas laws, you also think of direct and indirect relationships. A direct relationship is when something increases, the other increases as well. Another way of putting it is when one variable does something, the other one does it too. Remember when I told you about Charles' law? This is where the PTV stick really comes in handy. When you move the stick with a constant pressure, you see that the temperature and volume move the same way. That is a direct relationship. An indirect relationship is when one variable increases, the other decreases. Pop quiz! From your understanding of this video and gas laws, does Boyle's law represent a direct or indirect relationship? If you chose direct relationship, you're wrong. The answer is indirect relationship. In my example, when the temperature remains constant, the pressure increases and the volume decreases. Even though there are so many things that can go wrong while scuba diving, I would still like to try it out with my knowledge of gas laws. I will know to always hold your breath while ascending and properly store your gas tank.